All right, we're going to jump back and go back and finish some things we left off towards the beginning of the course. In particular, we're going to talk about polynomials in a more general sense. We started off with polynomials talking about linear functions, and then we talked about quadratics. Now we're going to go back and ask about what we can do with higher order polynomials. In particular, we're just going to ask about what's the general behavior, but also we're going to ask how can we figure out where is it positive, where is it negative, in the basic shape of the graph of these functions. So the first thing we do is define what a polynomial is, talk a little bit about behavior for large and small values of x, and then go from there. Okay, so we're going to define a polynomial. To be anything I can write in this form, and what's going to be important is this number here can't be 0. If it was 0, then I'd just be talking about the rest of it. Okay, and these things, these a's, are just some constants. Right? So examples would be something like h of x equals 17x to the 4th plus 3x squared minus 1. Another example would be g of x equals 8x cubed plus 3x minus 4. Okay? Now this is going to be, the degree of the polynomial is going to be this largest value here, the n associated with that, where this is not 0. So this is a polynomial of degree 4, that's a polynomial of degree 3. Okay? So we want to talk about first about the graph of these functions. And the question is, if I graph these things, right, I could look something like this. I don't know. The first question is what happens as x gets really big out here? Is it going to get big out there or very negative? And as x goes very negative, what's going to happen here? Okay, and it's going to depend on whether or not n is even or odd, and whether or not this number here is positive or negative. Then we're going to ask, where can we find the zeros of these things? We should say the intercepts, the x-intercepts. And then we're going to decide where is this thing, positive, negative, like so. Okay? So once we can figure out if it goes, which direction it goes, way out here and way out there, figure out where the all the zeros are, and then figure out where is this thing positive or negative. Okay? So let's go back to, so first we're going to talk about this, what happens way out for big values of x or negative values of x. We're going to call this end behavior. The thing to note is we're going to figure out which term matters the most. If x is a really, really, really big number, which thing is going to matter the most? So let me look at this thing here. That x to the n term, I can think of that as x times x to the n minus 1. And if I do that, notice now, this thing right here matches that. Okay? And if x is really, really big, whatever number that is, x times that is going to be much, much bigger. So what happens is, this term right here, if x is really big or really, really negative, that term is going to swamp out everything else. So this is going to be the dominant term, or the term that basically forces its will on all the other terms, because these essentially are very small compared to that. Okay? So what's going to matter here, if x is positive and x is really big, this is always going to be positive. So if this is positive or negative, that's what's going to matter. So let's see. So in terms of the graph of this thing, right, if x is way, way out here, then x to the n is going to be really, really big, like that. Okay? But that's only going to be true if this number right there is positive. If that number is negative, I'm going to have negative times a positive. And the whole thing is going to get very negative. Okay? Now, if x is way, way out here, x is very negative, we're going to have another problem going on. So what's the issue here? So if I have just x by itself and x is very negative, then it's just negative, right? If I have x times x and x is very negative, that's going to be positive. If I have x cubed, I can think of that as x times x squared. That's always positive, that's going to be negative, so that whole thing's going to be negative. If I have x to the fourth, I can think of this as x squared times x squared. That's always positive. X to the fifth, I can think of x times x to the fourth. That's positive, that's negative. So in terms of whether or not I get positive or negative, it depends on whether or not this n, the power, is positive, or sorry, even or odd. If it's odd, it's going to be negative. If it's even, it's going to be positive. All right, so what happens here is that if n is even, x to the n is going to go way out there. If n is odd, x to the n is going to get very, very negative. And then to complicate matters, if an is positive, I get exactly this situation. Right? I'm going to have positive times positive or positive times negative. If an is negative, everything flips. Okay? And so then I'll have everything coming up that way. So in terms of what could happen, I have four situations. Right? Two things can happen here, but for each of those two things could happen here. Okay? So what do I have? So in terms of the general behavior of these things, first thing I'm going to have is n is even. This value, an is positive. I can have n is even. Oops, sorry. This is an is positive. This leading term is negative. And I'm going to have two cases where n is odd. This is going to be the an is positive. This is the an is negative. So in this situation, what can happen? If n is even, an is greater than 0, this is going to get really big out here and really big out there. And then whatever is going to happen here, I don't know. I can have lots of things going on there. If the an is negative, this whole thing is going to flip. And I could have something like that. Okay? If n is odd, and the an is positive, it's going to get big out there, and going to get very negative out there. So I can have something like that. And if an is negative, basically this whole thing flips. This becomes positive, this becomes negative. So I can have something like that. Okay? So the question is now, how do we figure out what's going on with that? And in fact, next thing I want to talk about is how do we decide whether or not these things are positive or negative? Okay. First thing I want to do is talk about this idea of factoring these polynomials. And I'm interested in what happens when this thing is 0, like right there. So suppose this is some value a, and what can happen here is if I can always write a polynomial of degree n, for example that, is going to be x minus a times a polynomial of degree n minus 1 plus some b, right? So if p of a is 0, then this is going to be 0 times stuff plus b, which implies that b equals 0. So in this scenario, if that's a 0, I can write my polynomial in that form. Okay? So in general, what can happen? Okay. I can basically write this out in terms of factors. Okay. There's some exception to this if I have what's called a double root, but I'm not going to get too much into that. Let's just assume for now I can factor this thing out into some form. All right, we'll talk about these details later on in the class, about what the edge cases that can happen. But I'm just going to look at a special case like this. So I'm going to just do this through 2 examples. And what's important here is just the approach I'm using and just taking a very structured and nice, easy approach to how I'm taking this. So let's just assume I've already factored my polynomial. Okay, and in the next section, we're going to talk about how we actually do the factoring. For now, we're just worried about the general shape and what these things look like. Now notice, if I were to FOIL that out and then FOIL that out, I would get, so that would be something squared, and that would be something cubed. So I would get something like that. Okay? And if I multiply that 3 through, I'd get 3x squared plus a bunch of other stuff. I don't really care about the other stuff in terms of the end behavior. So, oops, that should be a 3. So in this case, my A3 is 3, and the polynomial degree is 3. So this 3 comes from there, and that 3 comes from there. Okay? So in terms of how to graph this thing, I need some extra room here, so let's be careful. When x equals 2, it's going to be 0. When x equals 4, it's going to be 0. And when x equals 5, it's going to be 0. Okay? So that means when I go to graph this thing, I know it has to go through that point, and that point. Because that's positive and it's an odd thing, I know it's going to get big out here, it's going to be positive. But I also know it's going to be negative out there. Okay? All right, so that means it's going to have to come up from below and go through that point. And I don't know if it goes through or comes back down or not. And then I know this is going to come from above and hit this point, and it may go through or it may come back up. I don't know. So let's see. So I've got this polynomial. First thing I'm going to do is look at what happens as I go from 2 to 4. So if my value of x is between 2 and 4, then, let's see, the 3 is a positive number. If I take a number between 2 and 4 and I subtract 2, right, so if I take any number between 2 and 4 and I subtract 2, it still has to be positive. If I take a number from 2 to 4 and I subtract 4, right, so if I've got a number in here and I subtract 4, that's got to give me a negative number. And the same thing here. So if I have a number between 2 and 4, it's between here and I subtract 5, it's got to be negative. Okay? So if I take a number, if I multiply a positive and a positive and a negative and a negative, I got to get a positive number, because negative times negative is positive. So that means it's going to be positive in that interval. And as x goes from 4 to 5, so I'm in this interval here, what is going to happen? Well, let's see. 3 is positive. Let me change my number line here. So where am I? I'm working with numbers between 4 and 5. So I got a number between there and there. If I take any number in there and subtract 2, it's still going to be positive. Okay. If I take a number between 4 and 5 and I subtract 4, it's still got to be positive. If I take any number here that's less than 5 and I subtract 5, it's got to be negative. So if I take a positive times a positive times a positive, get a positive number, but then I multiply by a negative, I got to get a negative number. Okay. So now let's see. Let's go back through now and try to graph this thing. I know it's going to be negative out here, positive, negative, and then positive. Okay. So it's just a very rough sketch of what this graph looks like. What's important here is where is it negative, where is it positive, in this general shape. Okay. Let me do one more example. Okay. Now, what's the general shape for this thing? Okay. Now the thing to note, so if I FOIL this out, I'm going to get an x squared. If I FOIL those two out, I get an x squared. So this is going to be like a minus 8 times an x to the 4th. Okay. And I know that because there's nothing in front of any of these x's. So if I expand everything and FOIL it out, I'm going to get a minus 8 times x to the 4th plus stuff. That means that out here it's going to be negative. Right? If x is very large, I'm going to have positive times negative. If I'm out here, x is very negative. X to the 4th is going to be positive times negative. So it's going to be looking like that. So out there it's going to be negative, out here it's going to be negative. Let's see. I know that when x equals minus 2, it's 0. When x equals 3, it has to be 0. And when x equals 6, it has to be 0. So I know it's going to go through these points. It's going to be negative out there, negative out there. I don't know if it's going to go through here or come back down. Same thing here or here. So I'm going to basically just step through and look at each interval separately and see what happens. So we have minus 8 times x minus, or x plus 2, x minus 3, x minus 6. We can clean that up. Okay, so if x is between minus 2 and 3, then, so what do I have? Let's do this. So I'm going to have x is between minus 2 and 3, and there's 0. If I take any number in here and add 2, it's got to go to the right of 0, so it's going to be positive. So let's see, so minus 8 is negative, that's going to be positive. If I take any number in here and subtract 3, it's got to go negative. If I take any number in here and subtract 6, it's got to go negative. So what does that mean? I'm going to have negative times positive is negative, times negative is positive, times negative is negative. So through here, it's going to be negative. All right, now as I go from 3 to 6, let's see, so now this is going to be on this interval here, minus 8 is negative. If I take a number from 3 to 6 and add 2, it's going to be positive. If I take a number between 3 and 6 and subtract 3, it's got to be positive. But if I take any number to the left of 6 and subtract 6, it's going to be negative. Okay. So that means I'm going to have what? Negative times positive is negative, times positive is still negative, times negative is positive. So this is going to be positive here. And the last interval I have to worry about is from 3 to 6. Oops, sorry, I just did that. So, oops, I put that in the wrong spot, sorry. So what do I have? This is going to be, oops, positive here. Sorry about that. Okay. So now for my function, it's going to come down here, it's going to be negative, it's going to stay negative, it's going to be positive, and then go negative.